So over the exponential growth and decay models, and they're modeled by a function that's equal to a subat e to the kt power, or a equals a subat e to the kt. And a subat, when you have a little zero that's behind that, that means it's your amount that you're starting with. So usually, and you will see that if you guys continue on in math, like you're going to have, like your initial velocity on some of our velocity equations would be v subat. And it just means that it has that little zero that's underneath it. And that indicates that it's going to be, in this case, since A is representing the amount, that it's going to indicate the initial amount for what you're starting with. So in this case, if on my function, if my function for k, which is going to be the exponent for my value of e, if k is going to be a number that's larger than 0, then you're going to have it going to be increase. And that makes sense if you remember from when we just graphed, like if I have y equals 2 to the x power. Remember function a little bit like this. Well, in this case, if k is going to be, if this number is going to be a fraction, then it actually just switches and it's going to be decreasing, it's coming down. And because of the fact that if it's going to be less than 0, that makes it negative, okay? That also would make my base negative. Like, so in other words, instead of having it being 2, it would be like x to the negative 1 power, which would be then 1/2. And that's why it's going to be decreasing. So when you look at the value for k, k is going to be representing, if it's positive number larger than 0, it's an exponential growth. But if it's k is going to be less than 0, then it's going to be an exponential decay. So it's going to get smaller and smaller and smaller. Notice on this one, on the smaller, I still have an asymptote on this one, correct? What would be my asymptote on this one? 0. It's never going to quite hit 0, but it's going to get really, really, really close. Okay? Increasing, I'm still going to have, they stopped it here because of the fact that it doesn't really make sense that I have a negative amount, but that's what it would be, it'd be similar, or a negative time. But in other words, this would still have an asymptote at this, when as t approaches 0, but it doesn't really make sense because of the negative factor. Goodness, I've got a frog in my throat again. So, the first problem, it says for the projected growth rate, k for a country whose population in 2020 was 27.7 million, and then in 2050 it is projected to be 54.1 million. Use the exponential growth model, a subat, and then e to the kt power. Okay, so in this case, what I want to do is identify some of my parts that I have. So what I'm going to do is, they're starting off when time is equal to 0, so t equals 0 at 2020. Okay, so that's going to be the start. I also have an initial amount, so a subat, what my amount that I'm starting with would be that 27.7 million as well. But then after so many years, at 2050, I have a projected amount. So my time for 2050 would be what? 30, right. And so you would have to assume that just from the dates that they give you. So t is going to equal 30 at 2050. And then what is my new a going to equal at 2050? Yep. Oh, 54.1. So in this case then, I know I have my initial amount, so I'm going to go ahead and start. I have 54.1 is equal to my initial amount, which is 27.7. I have e, and I have to the kt power. I don't know what k is, but that's the part that I'm going to look for. It says find find the projected growth rate, k. So I'm looking for k at this time. So I'm going to go k, but I have times time, and time is now going to be 30. So 30 k. Questions on how I got that? Okay, so grab your calculators. You're going to need your calculators for this whole lesson. So I'm going to start off with, I need to go ahead and just divide both sides by the 27.7. So I have the 54.1 divided by the 27.7, and that's going to give me an amount of 1.95, and I'm going to just do enough of it because I'm going to actually not use 0.95, but I'm going to actually go up and arrow up and grab that number. But it's going to equal then e to the 30k power. Now at this point I'm solving for my k, so that means I have that e that's kind of thrown in there. This is the one where we did that, we also solved yesterday. So if I have a value, what I'm looking for is the power here. What I need to do is take the ln, and the reason I'm choosing ln is because what is my base? E. I wouldn't use a log at this time because log would be base 10, and then this number here wouldn't simplify out. But if I take the ln of both sides and rewrite it, I know I'm getting kind of close to my number, so I would have the ln of 1.95, which is also in my calculator, is equal to the ln of e to the 30k power. Well, I can find the ln of 1.95 with my calculator. But on this side, I'm going to simplify it. What is the ln of e? 1. And what do I do when I have that to the power, like the exponent?
Just 1,
right? I actually will take it in front,
oh, yeah.
and I'm going to say, well, this is actually, I'm going to write it in 2 steps, 30k, because I know what my exponential, when I have a power, when I have a log to a power, I can pull that power out in front. That was one of the rules that we learned last week. But then I have the ln of e, which you just told me that this amount right here, when my bases are the same, that means that that's just going to be 1. So this part right here just changes to the whole number 1, because you're asking yourself, well, what do I take e to? What power do I take e to get e? And you're going to say, well, that doesn't make sense. It's just going to be 1. So then I have 30, but I can actually take my log. So I'm going to do the ln, and then I'm going to go ahead and arrow up. And so hopefully you guys have figured out maybe you can arrow up. So I can use all of those digits. And then I'm taking the ln of the 1.953068592. Okay? So I'm going to go ahead and go enter. And so that number right here is going to just change to something that looks approximately like 0.6694, and then it continues on. Okay? So if I have this digit here, and I have equals 30k, then my next step would just be to do what? Divide by 30. So I have it in my calculator. I'm just going to go divide it by 30. And so that was going to be then my k. My k will equal 0.0223. And in this case, they didn't tell us what we round to, but I think in your homework they will be very specific. They want you to round it probably to the 4 decimal places. And so in this case, I'd round it to the 4, which would be then probably to the 3, and it looks like it's going to stay. Okay? And again, this is where sometimes in this lesson, again, if you have problems where you've kind of rounded it off to like the 100th, make sure you actually take it to 4 decimal places or 5, and then a lot of times it'll work. If you can't arrow up like I did, take it at least to 4 decimal places, and then if you get down to the end and it's only a rounding error, just shoot me a picture, okay? Because I'll still accept it. It's just that the decimals will make a big difference. Oh, yes, I can do that. Does that make sense so far? So again, and notice that the value of k happened to be positive. K was going to be a number that was not a negative number. Therefore, that's also representing an increase and an exponential growth. So if we had gotten k to be a negative number, then something would have been wrong because we were not growing. Okay? So the next one is we're going to talk about half-life. And the half-life means that when you start with a substance, so if I start with 100 grams of any element, the half-life is indicating, they're saying, well, how long until it would get to be 50 grams? Or if I start with 200 grams, is how long will it take to get 100 grams? So that's what the half-life is indicating, is how long will it take for whatever amount of substance you start with until you actually get a half of that, a half of is left. And some of our elements will go very quickly. In other words, you have a half-life that could be as close to, within a couple of months. I mean, if it's decreasing, it's not a staple. You're going to have some that, if I take a rock and I say, what is the half-life of, like, carbon, it's going to be quite a few years because of the fact that it's going to decay. It's just not going to decay in a very fast way, okay? So when I do half-life, I want you to remember that you'll have A is going to equal 1/2 of A sub ot, always. Okay, so if you see half-life and they don't give you an initial amount, you will know that A, the other amount this we're equal to, will always be 1/2 of A sub ot. And what happens then, if I put it in my formula and I say, well, I have 1/2 times A sub ot is equal to A sub ot times e to the kt power, even though I can put some other stuff in, notice the first thing I'm going to do is divide both sides by A sub ot, right? So in this case, my A sub ots would cancel, and I'm left with just 1/2 is equal to e to the kt power. So it doesn't even matter if they tell you that they have a half-life of a certain element. This is really what we're going to start off with, because what you're saying is you're going to take, how long does it take my initial element, the amount that I start with, to get to be a half? Okay, and if I double it, what does this 1/2 change to? Well, if I double it, if I go bigger, like say it would be 2 times that. Or if I triple it, it's going to be 3 times that. And so the half is going to also represent anything. Like if instead of its half-life, it says how long will it take till it doubles, you're going to make this a 2 instead. Okay. And if it triples, it's going to be a 3. And that's how that'll finish out. Okay, so find the half-life for an isotope whose decay rate is going to be 6.3% per year. Now notice on this one, okay, they immediately changed that to a decimal. So they moved your decimal over 2 places, but they also made it negative. Why? What clue did you have that it'd have to be negative? They did give it to you. Decay. The decay is going to be the indicating that it's going to be a negative. Okay, so in this case, I'm going to let K equal then the negative 0.063, and then it says use the exponent K model. So what we're looking for is T. It says find the half-life. This is going to be then the T is going to be the missing part. We're going to say how long will it take to get to half-life. Well, at this point, I can just go ahead and say I have 1/2 is equal to E. I'm going to replace my K with the negative 0.63 times my time, and I'm going to solve for T. So in this case, all right, I've got it here. What would you do to both sides so you can solve for T? I'm going to take the ln of both sides. So I have the ln of 1/2, or 0.5, is equal to then the ln of e to the negative 0.063 t power. No, I'll put the 0 in there. Okay. So again, same problem we had before. I know I'm going to grab my calculator. I'm going to find the ln of 1/2. I can do that either as ln of 1 divided by 2. Okay, and I get that. Or I can also do the ln of 0.5 and just change that. Either one, notice I'm getting the same answer. Okay, so then I have then the negative 0.693, and then it continues on. Now again, this is going to mean that my exponent is going to come right out in front, and it's going to be then the negative 0.063, which is what they gave us, times t times the ln of e. And we know that the ln of e then just changes to 1. So it's times 1, so we really don't even worry about it. So the next step is that I'm going to divide it by the ln of 0.5 divided by a negative 0.063, and then I should have then t is going to equal 11.0023. So chances are they're going to say that the t is going to equal 11 then, a year, since it says per year, so it would be 11 years. Questions on that? Okay, so the next one, when I take, and this one is going to be when I take an aspirin, okay, or take some kind of medicine, they gave us that the half-life of that aspirin in our bloodstream is about 12 hours. Okay, so in this case, I know that I'm going to go a half-life, so it's going to be 1/2 of A sub aught is equal to A sub aught, then I have E to the K, and then it's times the 12 hours. How long will it take the aspirin to decay to 70% of the original dosage? Well, notice on this first part, this is going to be a two-step problem. I can find some information from just that first part, which is the half-life of an aspirin in your bloodstream is 12 hours. What I'm missing is what my decay model is. What is K? And so by doing that, I'm going to start off by finding K, and then I'm going to use that K to change it to my original dosage, and my original dosage is going to change. So notice that what happens to my A sub aughts? Yep, just like before, they cancel out. And I'm going to still go ahead and go the ln. I've got the 0.5 or 1/2. I can and then I have the ln of e to the. I'm going to change this and which these are 12k. So I just have the 12 in front. And so I'm going to again go ahead and do the ln of 0.5. Happen to have that from before, but let's go ahead and just put it in my calculator. I have the ln of 0.5. So I know that it's going to be a negative 0.693, and it continues on. But again, I'm going to move that 12 right out in front, and I'm going to have that's equal to 12 times my K times the ln of E. And at this point, guys, if you notice, what's ln of E going to do? Change to 1. If you guys don't want to write that each time, I get it. If it helps you to put that in there and say this is going to be 1, that's fine, but I'm not going to count off if you don't put that in there. But then I'm going to take that number and I'm going to divide it by 12. And so again, my K, and again, is going to be negative 0.05776. Now again, it's a decay model, right? It's going down. We knew that I had to have a negative number, correct? So then I'm changing it. My second part, it says how long. So in other words, how long is going to be your time? Okay, and we know that we don't want it at half-life. We want it at 70%. And so in this case, if it's going to be, can I change it to 70%? I'm going to change that to just 0.7. So I'm going to have 70% of my original amount is equal to my original amount. Now I'm going to go E. I have K, which is now the negative 0.05776, but now I'm multiplying it times my time. What happens to my A sub aughts again? Cancel. And again, just like you did before, since we're doing this again, if you didn't put that in, I wouldn't take off. But now, when I do this, I'm going to do this. I'm going to do 7 is equal to the ln of E to the negative 0.05776 t power, and I'm going to go ahead and solve. So I'm going to get and go ln of 0.7. Now it's going to change to negative 0.35667 is equal to then the negative 0.05776 t, and I know that I have times the ln of E, which is just going to be 1. And so what I'm going to need to do is I'm going to divide, and I am going to actually scroll up. And when I do my homework, I've always try and put just enough that I know which one it is. So that way I can just grab it and I can keep the entire amount, and then that helps it be a little more accurate. So T is going to be then 6.174. Now, again, before we were doing hours last time, so this is going to have to be hours. And it kind of makes sense. If my half-life is going to take 12 hours, that then they're saying is for 70% of it, which is not quite a half, is going to have to be less hours than you had when you started, than they gave for a half-life. How are we doing? Making sense? Okay. So the next one, they said use the exponential growth model. In other words, we keep seeing this formula come back up to show that the time that it takes a population to triple is given by this equation. Okay, so again, when we did the half-life, notice what happened. Remember we had the 1/2 a sub ot equals a sub ot, and then we always canceled out, and we were taking the ln of 0.5 or a half. Well, in this case, it's tripling, so that means that my A is going to equal then 3 times my initial amount. And then again, then I can go ahead and substitute that into my formula and change my A to 3 times A sub ot is equal to A sub ot e to the k t power. And again, what happens to my A sub ots? Yep, every time. So then the next step that you would do is you would go ahead and go the ln of both sides. So I'd have the ln of 3 is equal to the ln of e to the k t power. And then I would move that power right up in front, and I'd still say the ln of e is going to be 1. That's getting a little redundant, isn't it? So I have in this case, I have the ln of 3 is equal to k times t times the ln of e, which we're going to change that to 1. And so in the last step, they just said solve it for t. And so that means if I do that, I'm going to divide both sides by k. And so I have t equaling the ln of 3 over k. And that's what we did, is that's how we would show. It says, again, show that we use that model to get that. And so we got that same thing back. All right, and the last one is the growth model. And so what do we know about our t then, or our k? Sorry, our k. It's going to be positive. And notice on this one, our growth model is going to be 129 e to the a k, which is a positive number, times t, describes Mexico's population, A, in millions and t years after 2020. What is the Mexico's growth rate? So you could tell me from this model right here what k is, couldn't you? Yeah. What is it? 0.0106. Yep. So how long will it take Mexico's population to double? So again, when we did the triple, we took it times 3. So this time our A is going to equal then 2 times A sub ot. We're doubling our A sub ot. So my model then changes to, I can go ahead and just double it since I'm given an amount of A sub ot is going to be 129. I could go ahead and put that in and go 2 times 129. Okay, and I don't know, 129 times 2. 129 times 2, sorry, is 258. So I could either use that, or I can use the idea that it's just going to be 2. But let's go ahead and use the 258, and I'll show you what I'm talking about. So if I use the A is going to be 258, because I doubled what our amount was, is equal to 129 e to the 0.0106 t. The first step would be to isolate the e, correct? So I'm going to divide both sides by what? 129. And what is the 258 divided by 129? It's just going to be then 2, because we got that. We doubled it. So again, you could have skipped, with your knowledge of what we talked about with doubling, you could have gone from, you wouldn't have really needed to even put those two amounts. But we have 2 times E, the 0.0106t. Now what do I need to do to both sides?
ln.
Good. I'm going to do the ln of both sides. The ln of 2 is equal to the ln of E to the 0.0106t. And so again, I'm going to move my power right out in front. So I'm going to go ahead and go the ln of 2. And this time I'm going to get a positive number, 0.6931 is equal to then 0.0106t times the ln of E, which we already know we're just going to change this to 1. So the next step then is I'm going to divide that, the 0.6931 divided by the population, my growth rate, divided by 0.0106, and then I get the time to equal then 65.39. And again, since I'm looking for what I'm going to, since it was going to be t years after that, then this would have to be years. All right, any questions? We will do several of those.